So in this video we're going to go through how to prepare your data to create your IMS file to be used in the field when you're working with an alignment. So I'm just going to select in GEDO Office here, I'm going to select a new project and I'm going to select an IMS project. Just ask me where I want to save it, and file type is SIS. You'll get this pop up here, so it's just looking for some of the units to set for the project. These are fairly standard: degrees, minutes and seconds, meters, your cant base and your reference gauge. Now this is you're only able to set this at the start of your project, you can't change it throughout it. So it's important to get it correct. DB normal is the reference system. It's for Deutschbahn in Germany, but it's the same reference system base we use here for low rail, for cant and stuff like that. The vertical curve type, it'll obviously depend on what type of design you're using. You can try parabola. When you bring in the data, if you're not in the correct set the correct curve type, vertical curve type, it will flag this up and you're able to just start again and change that to circle and bring the data in again. So for this I'll just select OK. So for the IMS it requires a geographic location for your project. Now you could look up where the project is and find a latitude, longitude and height for it and input it here. For the start of the project you need to be within 50 miles of your project for the IMS system to be valid. Alternatively, we can just skip this here, and what you can do is when you're in the field you can go to the project settings and if you're using the TSE7 controller you can use the internal GPS, hit the here button and it will give you a position for where you are. You should always either put this in here or update it in the field. For this instance I'm just going to skip. So down the left hand side you'll have your commands here for your project. We're just going to be looking at the geometry at the moment to prepare our project. So if I was to go in and right click on the horizontal alignment, select import. I'm just going to navigate to where my track design is. Now you can select the file type here, so I'm going to go with XML. Here's my design string. When you open that there, it gives you this import selection, so it'll tell you what's available within that XML alignment. So we have a design string for the horizontal, the vertical and the cant, which I'm going to select. If you have, or hit select all, if you have a control file within the XML, this will be highlighted here. You'll be able to select that and import them as well. In this XML we don't have any control points, so we need to import them manually. I'll hit OK to that and we'll see here that it populates the horizontal, vertical and cant here with the information required. So it's important just to go through, for instance like this, and we can check to make sure that there isn't any faults or anything wrong with our design. When you do get something wrong with it, you'll get a little error message here just to warn you that the data contains errors. Now this can just be basically just to do with the file format, the way that MX puts out its files and the way it's expected to be read by GEDO. If you tap that there, it'll tell you. So I mean, it's basically telling you there's slight differences in the alignment change that amount to just over 0. If it's nothing substantial, it's just a format thing, we can hit recalculate horizontal alignment and it'll update that and correct it for the format required. Similarly in cants, you may find as well that you have a 0 cant and then up to 3 meters here we have another 0, then again at 3 meters we changed 10. GEDO Office doesn't like it that way, it just prefers it to go 0 and then it knows it's going to change it 3.6, so that might be something that will require editing. If you need to edit the design, you have options here to edit. Also, the aim here is that we're looking to produce an alignment that we can use in the field. So if you have these horizontal and vertical strings and the cant and they all have this matching name, it will create an alignment itself. So we're just going to go ahead and import the reference points as well. just be in CSV format for this one. Name, east and northern elevation. And then we have our control on the job as well. So within the alignment here, I'm just going to drag in my reference points into my alignment, and that's my alignment created. If it didn't create an alignment, you can highlight over it, create a new alignment. Give it a name, and then all we need to do is just drag and drop all our information into that alignment. So once you've created the alignment, if you highlight it there, it'll basically give you a schematic showing you how the alignment is in graphical form. You can also flip that into pan view, and we can see where our control is. We can just confirm to make sure that we have control within the job, maybe the spacing of the control points. If we hit show data here, we'll get some additional information such as the start chord, start chainage, end chainage, the reference points. We'll be able to see what the chainage of those reference points are. Some of the offset information, so you can print that out or note it down and take it into the field. So when you're measuring off the alignment at the end of the design, those should match up. And you would also have any tangent point information in there as well. So once you're happy with your alignment, it's just a case of over the project, right click on over the project name, export to GEDO IMS, select the alignments, either all alignment, one alignment, select your reference points, and export. Once the file's exported, that's it ready to use in the field. You can just move the SIE folder into your project data for GEDO IMS and open it as a project in GEDO IMS field software.